Hello guys. So I welcome you to the lecture series on real analysis. I hope you have already attempted the last three lectures. So today I'm going to start with function. Although we have already gone through what is function, okay, how we define it. Okay, basically how we define function that say S and T be any two non-empty sets. A function f from S to T denoted as f goes from S to T is a rule which assigns to each element of the set as a unique element in the set T. This means what? For every element, means say X belongs to S, then we will find Y belongs to T so that f of X is equal to Y, right? And we also got to know that this S, this particular set, S is known as domain of the function and T is known as codomain. Then we have found the image, means we have defined image. How we defined it? If an element X in S corresponds to an element Y in T under the function, just I have told you what is that, then this Y belongs to T will be known as image of X. And we express it by writing how Y is equal to fx. Okay. So this thing is clear. Then we define onto and into function. The set fx where for all x belongs to S, which is a subset of T, is called the range of f. मतलब जो images का set है उसको हम क्या बोलते हैं? We call it as the range. And if you find that range of f is equal to codomain of f, then that function f will be known as onto function, or sometimes we call it as a surjective function. Okay. Otherwise, if it is not equal to, if the range is not equal to codomain, then we call it as an into function. Okay. These are the recap of the terminologies that we have discussed in the last lecture. Right. Let's come to another topic, that is identity function. Okay. Identity function. Now, say SB and non-empty set, a function f goes from S to S. We define it as f of x is equal to x for all x belongs to S. ठीक है? How we define it? Say we define a function f from S to S, and f of x is equal to what? X for all x belongs to S. Then this function f will be known as identity function. I hope you may recall the concept of group. Yeah, guys, I have one more lecture series on the subject abstract algebra, right? You will find the link. You may search it, or you will find that link in the description box. Attempt those lectures. There I have defined groups under the group theory portion of abstract algebra. And there I have defined, we have actually gone through the properties or axioms of group and their identity element concept. You'll find it. Okay, same here. Now, we call that function as an identity function. F goes from S to S, so that for all x belongs to S, we have what? Fx is equal to x. And we denote this identity function as I. Okay, capital I. With respect to the set, say S. It is very easy to say that this is 1 1 and on 2. Now one important concept, that is what is 1 1 and what is on 2. So let's define these things, that is 1 1 and on 2. So a function f is said to be 1 1 if distinct elements in the domain of f have distinct image, or in other words, we can write fx1 is equal to fx2 implies x1 is equal to x2, where x1 and x2 belongs to the domain of f. Got it? So how, I mean, in what situation we call, in what condition we call f this function as an 1 1? कब हम बोलेंगे? That is, say x1, f of x1 is equal to f of x2 when x1 is equal to x2. ठीक है, इसका मतलब क्या है? हर एक डिस्टिंक्ट एलिमेंट्स के लिए एक आपको डिस्टिंक्ट इमेज मिल जाएंगे, कहां पे? कोडोमेन में, राइट? ठीक है, सो एवरी distinct element of the domain of f have distinct image. Okay, so agar x1 is not equal to x2, so this function f will be on to sorry 1 1 if f for x1 is not equal to fx2. Okay, is this clear? So that is 1 1, right? I am repeating the definition again. A function will be known as 1 1 if distinct elements has in the domain of f have distinct image. Now we define onto also. Onto क्या है हमने देखा था, ठीक है, into and onto, right? So अगर a function is both 1 1 and onto, then we call that function as bisection or 1 1 correspondence. So please note down what is bisection. Bisection, what is bisection or 1 1 correspondence? When a function is what? Both 1 1 and onto. Onto क्या है हमने देख लिया था, what is onto, right? So 1 1 अभी हमने देखा कि distinct elements के लिए distinct image रहेगा, ठीक है? तब 1 1 और onto हमने कैसे देखा था, क्या था onto? When codomain which range equal to codomain, then we call it as onto. मतलब जितने भी एलिमेंट्स आपका कोडोमेन में हैं, ठीक है, वो सारे इमेजेस हैं किसी किसी ना एलिमेंट डोमेन का, ठीक है? तो if range is equal to codomain, then we call that function onto, and if all the distinct elements and distinct have distinct images, we call it as 1 1. And if both 1 1 and onto, then we call that function as bisection or 1 1 correspondence. That's it, right? तो आइडेंटिटी फंक्शन जो है वो क्या है? 1 1 एंड onto बोथ होगा, क्योंकि हर एक एलिमेंट का जो इमेज क्या है उस वही है. So if a function s f goes from s to s, we define as fx is equal to x for each x in s, then that is identity function. And for identity function, we easily verify that this is 1, 1, means distinct elements have distinct images, and onto means that is range is equal to codomain. Right, that's it. Now, next thing is constant function. What is constant function? Okay, let me clear this. First, we will read the definition. Let S and B any two non-empty sets. A function f goes from S to T defined by fx is equal to C for each x in C, where C is a fixed element of T, then we call it as a constant function. Okay, so S and T, these two are non-empty set. Okay, so non-empty set means at least any one element belongs to this set. Then we define the function what? F goes from S to T, right? Now, for all x belongs to S, we have fx is equal to, say, a constant C. Okay, then this function f will be what? A constant function, right? क्यों constant function? मैं एक बार फिर से दिखा देता हूं, क्योंकि जो भी एलिमेंट्स, जितने भी एलिमेंट्स S में हैं, उन सब का इमेजेस क्या है? एक कांस्टेंट वैल्यू है. For every element of S, okay, its respective image value is a constant. So the value is not changing. That's why this is a constant function. So example, say f goes from S to R, defined as fx is equal to 2 for every x in S. हमने एक function define किया है. We have defined a function f goes from S to R. On how we define it? Say fx is equal to 8 for all x belongs to S. Then this will be our constant function. And if you plot the graph, आप अगर इसका ग्राफ प्लॉट करोगे तो क्या होगा? देखिए, ये x है, this is x, and this is y, right? So this is say 1, 2, whatever the value of x we have, say this is 1 and 2, this is say 8, right? And this line is passing through 8. So x value may be changing 1, 8, 2, 8, say 5, 8, but y value is same everywhere. माने क्या हुआ? जो y का value है वो change नहीं हो रहा है. Y का value means what? That is the image. Okay, so the image is not changing. That is constant. So this is a constant function. That's what I mean to say. So the concept of constant function is clear. So I'm repeating again. If any doubt, if you have, or if you find difficulty in any concept that I'm discussing, please use the comment section to ask me. In that way, we can make our lecture series more interactive, right? So let's come to the next topic. Equality function, equality of function. Any two functions with the same domain are said to be equal if for each point of their domain they have the same image. Thus, if f and g are any two functions defined on a non-empty set S, then we have what? F is equal to g if fx is equal to gx. So, in simple words, we have the two functions. Now, these two functions will be known as equal functions. Okay, will be said as equal if fx is equal to gx for all x belongs to S. Okay. And this S is what? On which we define these two functions. So, in other words, we can say that these two functions are identical. Right. So, I hope this equality of function concept is clear. Let's move ahead. Now, next thing we are going to define or discuss is composition or combination of two functions. And the question on composition is maximum times asked in the semester examination of different universities. And also you'll find one question in the competitive exams also. So we are considering, say, S is equal to 1, 2, 3, 4, T is equal to 1, 4, 9, 16. And N is the set of these natural numbers. Now we define F goes from S to 3. And this is what? Fx is equal to x square, right? For all x belongs to S. Now, say z goes from t to natural numbers. And how we define gx as, this is z, cx is equal to what? X plus 1. Okay, for all x belongs to t. Now, by the function f, an element x belongs to S is mapped to fx is equal to x square. Further, by the function z of the element fx is mapped as fx plus 1. That is what? X square plus 1. And we'll denote this as z of fx. So define a function h s to n by hx is equal to zfx. And this function maps x, that is x in S, to some unique elements of what? Z f of x, that is x squared plus 1 of n. And this function h is known as composition or the composite functions of f and g. So how we are actually doing the thing? See, fx, we got it, fx is equal to what? X squared plus x squared, sorry, x squared. Now, z of fx, cookie, z of fx will be what? Z of x squared, right? And g of x squared is what? X squared plus 1. So this is, say, sx. And this is known as composite function, and this is actually mapping from this initial set S to direct the third set N. Right? Now, definition is, say, let f goes from S to T and g goes from T to V be any two functions, then this function S goes from S to V, denoted as H is equal to Z naught F. We denote it as Z naught F. And we define it as hx is equal to g naught f, x is equal to z f of x. Okay, z f of x, right? This is the concept of composite function. So guys, today I'm not going to extend the class more. Okay, I'm closing it right now. And tomorrow I will try to take 1 hour lecture on this. So by tomorrow, try to go through this lecture again, and if any doubt occur, to ask me. So we'll meet in the next class. Till then, take care. Bye bye.